Hey everyone, welcome to my next video. Today it's not about the STM32, but a little project I've been working on. So in this project, the side goal was taking an image recognition software to recognize faces from an image. And for that I was searching along and found quite some options, and because a friend recommended to me, I opted for the IBM Cloud option. There are loads of open source one, there is even OpenCV, but I hadn't had the chance to play with it, but this is just a show from what I did. So in this project I had to relearn a little bit of Python because the IBM includes a little bit of code for the Python, so you can get started there, but also for many other languages. So what I have opened here is a sample project that I have available for you guys as well. It's on GitHub. We can go to it right now, and here is my repository. So you go to the repositories, the latest one, the face recog, is the latest one, and here is the readme. You can go through it. The installation and the usage is all described over here. And what I'm providing you with is a folder with 3 photos, and each photo has a 1 person, 2 person and 3 person on the photos, and a sample photo over here in the root directory called the sample image. There's also the marked image, so you see what the result will look like, and this is the result. This is an image from a free image from a site, so the link for the image is down below. But this image that I used has 4 people, and over each of the faces there's a rectangle marking the dimensions where the software has recognized the face, and the number. And the number has a purpose for linking the person's face to an output on the terminal, because the software also gives it back the face's gender and the estimated age limits, so the minimum and maximum age. So that's gonna be, so this is what the finished project will look like when you use this code. So it has a little bit of dependencies. You have to have Python installed. I use Python 3 because there's a workaround around annoying Pygame bug when it sends a little bit of string when you import it into the terminal. So we use another project, actually another library that it's only available for Python 3, but you can use Python 2 because I started this on Python 2 and worked well. You also need to go to the IBM page. Here is a link for the cloud and the link for image recognition. If you click on it, it will take you to the introduction of this API for the image recognition software, and you have all the code and on the right and all the descriptions on your left. And the first one goes into the cloud. So if I go into my cloud, this is what your portal will look like. You see that I have a test account, and this is a lovely display. The first plan is free. If you have I think up to 1,000 requests per month, this is free. So every time you use the service and send something to the server, it's called a request. So you have 1,000 of those per month for free, and then there's somewhere is usage. I think it's 0.4 cents for any request. Either you send an image to be recognized or use machine learning on anything else. I think it's about 0.2 to 0.4 cents per usage. But I have this service opened right now, and when you create a resource, let's click the create resource, and then it takes you to this site when you can create loads, like 59 things different you can do. And for our case, we're gonna just search for visual, and you have visual recognition, and you click on it and you can create your project name and everything else. Here's all the features, and here it is. The light version is 1,000 events per month, so it's pre-trained classification or costume model, and every event is called only 1,000. And also it gets deleted if it's inactive. And here, okay, here's the pricing. So general event is 0.2 cents, facial recognition is 0.4, training is 10 cents, and so on. So you can look at this if you want a bigger plan. So, and then when you create a face, prepoznava obraza, this is in Slovene face recognition. This is because I'm doing for a project here. And then you get your API key and URL, and you use this API key to put it in your code, and I'll show you the code right now. So keep that a secret because the key is linked to your project. So if another one gets your key, then he's going to be using your API and your service. Remember, you only have 1,000 for free. So let's go to our code, and here's I have multiple repositories and one folder is the Git folder, which I will not change anymore unless there's a change in the actual structure of the code. And this is the one that I have opened. It's in the Git code repository, and over here you have to insert your key. But I'm gonna be running code from my finished folder, which is the same as this one, but it has my API key inside, so it's not publicly available. So we're just gonna run code from this over here repository, but we're gonna look the code because it's exactly the same. But we're gonna also looking at the received file, which is gonna be in this finished result. So we're gonna look at it live. Just a word of warning, Python is not my first language. I used to do a little simple things in high school. It was about 5 years ago, and I haven't touched it since, and due to the nature of the project I had to work with it because one of the languages that was closest to me, which is Python, was offered by the IBM Cloud. So everything I did in the course of a few days from scratch, basically zero knowledge. Only knowledge I have is from programming in C for microcontrollers. So let's go over a few things. You're gonna need a few packages. Some are already installed, like OS, sys, and JSON. And the one that you will need to install is IBM Watson, the Pillow, ContextLib, and Pygame. And maybe Wheel. In my repository I mentioned Wheel as well, because in the installation of IBM Watson there was an error that it didn't recognize another function. So please, when you go through the installation, check if it has any other errors. It will usually give it out which one it is, so you can search it online and install that additional packages. So this is the part where I had to use Python 3, install all the packages again for Python 3, and installation instructions are on the IBM page and on my repository. I had to use ContextLib to redirect in this case, but to shut down this importing. When you import these two packages from Pygame, there's a printing on the serial terminal, like thank you for using or something like that, and it's annoying if you just want to keep your terminal clean. So every time you run this code and import these two libraries, then it prints that. So this says that when importing these two, redirect the standard output on the terminal, so nothing gets outputted. So you have to use Python 3, but you can use Python 2 if you don't mind this. But you cannot use ContextLib then in Python 2, I think. I searched about this. Then I have 3 more global variables. This code is not optimized, obviously. I'm not fluent in Python, so this code is not the best it could be. So I had to use 3 global variables because I partitioned my code into function, as I like to do in the C code for microcontrollers, as you might know. And I partition code with these hashtags because I like to keep it clean, so I knew where the limits of a function are, so I can manipulate through the code fast. It is long for something that's so integrated, but it's very short. So let's start with main. So here's the main loop. These are all functions above this, or maybe let's start before the functions. Here are some declarations for the sample images. So I have 3 sample images for you in the photos folder, subfolder, with 1, 2, and 3 people on the image, and then a sample image as well that can be accessed a little bit faster, and a photo.jpg. This photo will be used when you take a photo with your webcams, because I also implemented that. So let's go to the main code quickly. So the first thing that the terminal will ask you if you want the camera image or not. If you want to, so this is checking if you want to, then into a kind of global variable image m, I called it the master image variable, you put in the name C image. So this is a shortcut for the photo JPEG. So this is the camera image that are gonna be saved. So this is a global variable IMM or master image, which is gonna be updated according to the selection in the terminal. So if you select the camera, the IMM is gonna be C image, and then we're gonna change it later if you want anything else. Then it asks you if you want to make a new image. Maybe you have the same image from before and don't want to make a new image and waste time with making a new image, so you can click no. And if you want to make a new image, then it's gonna call a function getNewImage, which is gonna take a new image, and then it's gonna evaluate it, and it's gonna get all the faces from the image, and then it's gonna call the main function, which is taking information out of the parsed file and then drawing those rectangles over the faces, and then exit the code. If you don't want to make a new image and you want to use the previous, do you want to reprocess it? I use the reprocess clause 2 times because when you're debugging, or when I was making this code, I didn't want to waste time by sending the code to the cloud every time. I want to just test other parts of code, like main part of the code. So I would put this inside so I can just click any other button besides yes or Y button, just to bypass the evaluation image. But if you want to, the evaluation image command will initiate. This is the one that's gonna send the photo to the cloud. But if you don't want to, it's gonna still get the faces from the images and draw rectangles and numbers and exit the code. If you didn't want to use the camera, then it's gonna ask you which image store that you want to use. 1, 2, 3 or S, calls for the sample image that it's on the root. 1, 2, 3 are the one that are in the folder photos. And then just simple, if you choose 1, then the master image variable will into it will be copied the path to the image 1 or image 2 or image 3 or sample image. So these are the ones over here. And okay, so this is just for selecting this variable. Else, if nothing of this was selected, there's no image that you put in, so wrong input. And then it's gonna ask you if you want to reprocess image again. If you want to, you put in eval image command. If not, just get the faces from the image file and draw frames and exit. So this is how the main code is going. Pretty intuitive. That's why I break it off into multiple functions. It basically put it in multiple functions for the purpose of debugging. But if you don't want to use this, you want to reprocess image, just merge evaluate image with get faces, for instance, and then main. I used to call main multiple times to draw multiple frames around people, but then I just figured out I could just use a for loop. That's why I put in a parameter into the main called no faces, and this is why I had to use some global variables. In this case, IMM is a global variable, no faces is a variable, image name and faces. This no faces variable will hold the number of faces. Faces will hold the data about all the faces, and image name will hold the data of the image that was parsed to the server. So if you look at the result is going to be a JSON formatted file, and it's going to look something like this for the sample image with 4 people in it, so this one. So you see it's going to return images and then a list array, or I call it array of multiple, because they're going to have multiple faces. Here is the first one, which is this one. Oh, it highlights the first one, so the 0 person, the 1 person, 2 person, and 3 person. And then it's also gonna put in the image that was given to the server. So this is the one that I receive and put into the variable image name. So we can confirm the right image was sent. Also, I don't care for the image processed one, but if you want to, it is here. And then we have faces, and then we address each face particularly, and we extract age, face location, and gender. Face location is used for the frame, gender and age is just for little facts if you want to put them in the terminal. So if we look at the code in action, let's type python 3 and facemark.py. I don't want to use camera image, I want to use the sample one on the root, and yes, I want to reprocess it. It's gonna send image, and then when it gets the image back, it will print, yes, it's the sample image.jpg was sent, face 1 is male, and then the sureness, and then it's at least 33 years old and 36 years old with sureness of this percentage. If we go here, the person number 1 is this guy, person number 2 is a female, that's her, the person number 3 is also a female, and the person number 4 is also a male. So this is quite correct with high percentage, and this percentage might depend on the quality of the image as well. So let's go through the functions. So one of the function is get new image. So this is the function you would call if you want to make a new image with your webcam. So the first one is going to use Pygame. It's going to initialize the camera and the first one in the list, because I only have one webcam plugged in, so it's going to use that one, but you might need to change this depending on multiple cameras. And then it's going to start the camera, get the image into the image variable, then gonna stop the camera, and it's gonna print image taken, so for debugging purposes you know where in the code you are, and it's gonna save it into the photo.jpg. So this is this one, which is gonna be used by the variable see image, and then it's gonna quit the module, and that's it. That's the get new image variable. And then the next function is evaluate image. As you can see, these functions are also listed in the order they would get executed at any given point, with or without. So if you want to execute get new image, you're also gonna eval image, get faces, and then main over here. Or if you don't want to get new images, you're gonna evaluate image and get faces and then main. Or if you don't want to evaluate an image, it's also is already evaluated, like in this case we already have the JSON file on our folder. So if you run this file again, we don't want to use the camera image, we want to use the sample image. So this is the one, so this is gonna know where to draw, but we don't want to reprocess it. So as you can see, it did it very fast because it already used the files, the JSON file that was already processed before, and the image, if you open the image, is still okay. So the eval image is gonna get the image size, and first this is because if you have a large image it might upload it for long. I have a crappy internet connection, about 250 kilobytes per second upload, so it takes a few seconds if it's a multi-megabyte image, so I limit it to 1 megabyte, and if it's 1 megabyte or more, we check it with this. Then we're gonna open the image and save it back in a lower quality. I found that even at the 25 quality it's still good enough for the very good results. But if you change the resolution of the image, which is the first thing I was doing, then the sureness of the gender and the age drops very fast. So might better results by just lowering the quality than changing the resolution. Okay, then is the API part. This is the standard part, is described in the sample file from IBM. So initialize a new variable with the correct version and your API key. You just delete all of this and replace it with your key. This is big dotted one over here. And then, well, I'm sending an image when you replace this, because yeah, it's sending an image right over here. and take the image and get results. So this is sending an image. So it's gonna open the image as read, and then execute this command. It's gonna use the detect faces. Image is the source. You can replace it with URL equals and then put in your URL to the image. So you can do this way as well. But I use a local image all the time, but you can use URL as well, and then get results. And it's gonna dump the JSON formatted file, all the data into these faces, and then it's gonna say, yeah, it was received. And then we open as write a new file, or if it's existing, it's just gonna open it and dump in this data with an indent. If you don't use this, it's gonna be just one long string. It's not gonna be formatted nicely like this. And this is it. So this is gonna evaluate image on using this service and write it into a JSON file. Then we do that, we get the faces. So with global, we didn't use this function before. In Python, you use global to import these variables. If you just use this variable, the Python will create new local variables inside the function, but when we define global, it knows it's searching for these variables that's global over here. So we get, we open the JSON file and load the data into this variable called data. And then comes the JSON file, getting data out of JSON files. You get data out of JSON file, but first you open the JSON file and then you take images. So the first one is gonna be images. So the first bracket is gonna be images. So search for images. So this is data bracket. It's like an array basically. Search for images, and then when you go into the images, the image name will be, so the first thing is faces. So this is all faces, and the second thing after this bracket is the image. So the image is the second item in the faces. So this is the image name. So you get images and go into the first array of the images. So this is the first one over here, and then we get into it. So it's gonna include multiple. So this is this one. It's gonna include multiple. So it's gonna include faces and it's gonna include the image. So when we get into the first one, then we go into the image, and then we get into the image. It's gonna take this. So the sample image.jpg is gonna be imported into the image name, and then we're gonna use faces to shorten our codes. As you can see, we use faces a lot over here, and if you didn't do this, then this code would be longer for no reason at all. So we use faces for shorter code. So faces is the same. Images, the first part of images, and then everything labels faces. If you go up, here is the faces. And if the faces is empty array, then it's gonna say no face detected and exit the code, because you could get some errors. And then it's gonna get the number of faces as well, so we know how many times we need to put brackets around the faces. So you just use length of faces because it's just an array, so we can do this like this. And I'm gonna print the process image was image, so that we verify which image was evaluated. And then we go into our main. So the parsed info of the main is number over here, but if we go back, the main gets no faces, and no faces get defined here. It's a global variable on the number of faces. And why is this used? Well, let's firstly open an image, get its width and height, and then I define the line thickness to be adjusted depending on the resolution of the image. So you don't have a small resolution image and it's gonna be thick as hell, and you're gonna have a large resolution image and it's gonna be a very fine line around the faces. So you want it to adjust with the resolution of image. So I used the minimum, so it's gonna find the shortest side of the image, either width or height, divided by 1000 and add 1, so it's at least 1 pixel wide. So this is line thickness, and I experimented with 100, so it looks a bit right. You can lower it or higher it. And then when we get this information, we can draw all the rectangles and numbers, and then in the end just save the image. And that's it. That's all the code. So I used to just run main a multiple of times, but this is a cleaner way. Just put in a for loop, that's gonna go from 0 to a number. So this is not including, so this is in C equivalent of less than, not less than equal. So it's not like this in C, but it's just this. So I was confused. I thought it was going to include this number. So if the number faces is 3, it's gonna go 0, 1 and 2, because computer starts counting at 0. So the first thing is get coordinates. Again, we use the faces, and then which faces? There are multiple entries in the faces. This is the first one, this is the second one, this is the third one, and this is the fourth one, because we have 4 faces. So we get the x one, so, or either the number of faces in this case are 4, it's gonna be which iteration of this for loop it is. So the first iteration is gonna be 0, so x is gonna be 0, so faces 0, so the first face, and then the second, and then third, and then fourth. We want to use the face location left. So this is the, I had multiple, so this is the first coordinate, so it's x1 and y1, and the second one is x2 and y2. So if I open the image to explain a little bit better, which face, let's look at this nice bearded man. So the way the image gets processed for the location, the starting point is always on the left top corner. So this is 0, 0, the start of the coordinates. And then it's gonna be positive width and positive height. So the way that this server returns data is it returns height of the image, of this frame that should be drawn, of the face, width of the drain, and the leftmost point and the topmost point. So in the context of the image, this is the leftmost point and the topmost point. So in essence, it gets this coordinate and this coordinate. And then using the width, we can get this coordinate, and height we can get this coordinate and this coordinate. So we can draw all the face. So in that, the x1, so the starting one, which is this one, so the first, so going from down height over here, so this is the y, it's gonna be top, so this is the length from the top to here, so that's why it's labeled as top. And the x1 is gonna be the one going from left to here, it's gonna be left, from the left, the most. And then this one is just this one plus the width, and this one is gonna be this one plus the height. So it's gonna be, width is gonna be face x plus face location, the same one but width. And the y-axis, so this one is gonna be face y, this one, plus height. And that's how we get coordinates. And then we're gonna get gender, it's again x, and it's gonna be in its own gender and age as well. So it's gonna just address this one. So it's gonna go gender, and this is gonna be the gender, and gender score is stored in the faces gender score. And I'm multiplying by 100 to get %. And age is the same, so you go into the age min, age max, age score, and multiplied by 100 to get the %. And then it's a little bit of printing, so we print the face. Integer is a string gender, which gender, and the sureness is a float with 5 decimal precision, just to not overcrowd the terminal. And then faced integer, which is at least string this years old, and the most this years old with sureness of this and this %. And we can see here the first input is the face which one, so because the computer is going from 0 to x, so in this case it's going from 0 to 3 because there are 4 faces, but I'm labeling from 1 to 4, so I'm just adding +1, so it's labeled from 1 to 4, it's not from 0 to 3, so this is just a convenience, but you can change that. Age minimum, age max, and age score, and here is the gender and gender score as well. Then is the drawing face part. We define the font size in points, or what is this called? Not in pixels, but there's a equation showing the relation between size in pixels and size in points. If you need this equation, it's over here. But we get a size point also. Again, it's gonna be variable depending on the size of the face. So we don't want a large font of this number just because this face is very far away in the image, or very large because it's very in front of the image. So we want to proportion it as well, like we did with the line thickness. And that's what we do again, between a minimum of the face x2 minus x1, which is the width, and the face y2 minus face y1. So this is gonna get the minimum side of the face frame. And then it's gonna draw it. We initiate a draw variable with the image. So again, image has been imported in the beginning. So it's gonna get that image, and then it's gonna get a font. I'm using this font with the font sizing point. I also experimented with this one, so it's staying relatively consistently great. And but you can use font sizing point and multiply it by some number if you find this font a little too large or too low. And then we get the position of the text, so it's in the center. So if you think about it, this frame is gonna become this image. As I talked about in this image, the starting point is here. So let's create for the frame as well. Let's say the starting point is here, and the center is half of the width and half of the height. So this is the center of this frame. But the number is also gonna be drawn from its left corner. If you think about the number is also gonna have a little box. So if you imagine a box around the number, so this is the text box, it's gonna have a starting point from around here, so it's gonna be drawing this way down. So if you start at the center of this whole box, then the number would be somewhere in here, because the box of the number would start in the center, but it would be like this if you follow my mouse. So that's why we need to shift this number from here up here. By how much? Well, we just need to shift it by the half of the width of this number and the half of the height of this number. So we put it back onto here, so it's always centered over here. If you didn't follow it, maybe take a pen and a paper and just draw it yourself. I did this on my whiteboard, and that's how I got to the equation. It's nothing really, or replay this clip again if I was not clear enough. So we get the middle point of the square, so the x position is gonna be x2 minus x1, so the width, and divided by half, so we get the center. So this is the center for x-axis and the center for y-axis as well. And then we add the x1. So we get first this distance, but then this distance relative to the starting point would be somewhere in here, because the half of this frame would only reach to about here. So we need to add the x-coordinate of the start of this frame. So we add x1, and then we add the half of the frame. So this is what this line means. But then we need to shift it a little bit up for the number, because it takes some space. And we get that by using font get size. So it's gonna get size of the string that's gonna be put inside it. So it's gonna be put x plus 1. So remember, we just plotting numbers from 1 to x, not from 0 to x. So we're gonna x plus 1, so this is the string that's gonna be printed as this text. So you get the size of this, so it's gonna get size depending on this setting as well. And then it's gonna get the first one, so this is the x coordinate and this is the y coordinate, and then divided by half. So we're just going left and up for the half of the dimensions of this number. So that's how we center this number in the center of this frame. And then we do this for the box. So we draw text at these coordinates that we defined before. We print in this string with this font and with this fill. This is the RGB value for red, and with opacity of 100%. And then we draw lines. Basically, we draw lines from x1 and y1, so this is this coordinate, and then we go to x2, y1, so x1, y1, x2, y1. Then we draw another one from this to x2, y2, and then from x2, y2 to x1, y2, and then one another back, x1, y1. So we draw 4 lines with this fill, so this is the red color, and this line thickness that was defined in the beginning. And then when we do this x times for x number of faces. Then we just save the image as a new image called markedimage.jpg in the root, and that's it. That's all the code. I think it's, well, I made it so it's very fine of me to say it's simple, but it took a long time. But I'm satisfied for how it works. Let's use another image. No, I want to use then, let's say, this image. And yes, I want to reprocess it. Oh, and we get an error. That's, I use again, maybe there's another definition of the image. Let's use XS as well, if the cloud works still. So it's uploading the image. Yeah, it works. I'll have to check the image, what's wrong with it. But it works, as you can see, so you can replace the sample image and other images as well. I probably redefined something so it put a nasty error out. Anyway, this video is already, goddamn, very efficient at making long videos like nothing. I'm having a whole day of school behind me, so So if you want to play around with this, feel free to go to my GitHub repository and comment if you have anything to add or any requests for any fun projects. So thank you for watching, and I'll see you next time.